Welcome back to another one of my vectors and scalars videos. This is focusing on the dot product, or as known as the scalar product. This is the second video, just to give you some more examples. So let's get right into it. So the dot product will, when you use the dot product on two vectors, it gives you a scalar value or a scalar quantity. And if you find it, when you want to find the angle between those two vectors, you use this right here, and you rearrange to solve for theta. And over here, if a dot b, or the dot product of a and b equals 0, that means that they are orthogonal to one another. So that means the vectors, if you put them tail to tail, they'll be at 90 degrees. Or if you put them head to tail and you sort of follow it on up, and then you measure the angle from there, it'll be 90 degrees. Okay, so let's get right into it. So example 1 will be a equals 2 in the positive I direction and 3 in the positive j direction. B will equal 5 in the positive I direction and 1 in the positive j direction. A dot B will equal, well, we multiply the two I components together, so that's 2 multiplied by 5, and then we add that by the j components multiplied by one another, so that's 3 multiplied by 1. Okay, and that will equal 10 plus 3, and then that will equal 13. So the dot product of this a and b vectors will be 13. Okay, so we're going to use these values in our next example, because the next example will be finding the angle. And we're going to need the dot product of a and b, and I don't have to work that out again. We're going to need the magnitude of a and the magnitude of b, and we're going to use that to solve for theta. So, we said that a dot b was 13. The magnitude of a is the square root of the I component squared, which is 2 squared, plus the j component, which is 3 squared. And then we're going to multiply that by the magnitude of b, which is the I component, which is 5 squared, plus the j component, which is 1, and square that. And then we have cos theta just hanging out, waiting to do something. So we're going to grab 13, we're going to divide it by the magnitude of a, then we're going to divide it by the magnitude of b, and the number we will end up getting is 0.707, and that will equal just cos, now that everything else is gone. Now we multiply by the inverse of cos, that means now we'll have the inverse of cos, 0.707, and that will just equal theta. We'll get theta on its own. And if we put that into our calculator, theta equals 45 degrees, which makes sense because here we have a is going across 2, so here's our starting point, it's going across 2 and up 3, which means it'll go up here somewhere, and then b is going across 5 and then down 1, so it'll probably be over here somewhere. And basically, if you followed this up and measured the angle between, that would be the 45 degrees. I got a bad drawing, but that's what it is telling us it will be. Okay, so now we're just finding, in this last example, if these two vectors are orthogonal, which means a dot b equals 0. And I've got two new vectors using the same letters, but they're two new vectors, -3, -9. And then b will equal -3 and 1, which means it's going 3 in the negative I direction, and this is going 9 in the negative j direction. This is going 3 in the negative I direction, and this is going 1 in the positive j direction. So, a dot b, that will equal the I components multiplied by one another, so that's -3 multiplied by -3. And then we add that to the j components multiplied by one another, so that's -9 multiplied by 1. And then that will get -3 multiplied by -3 is 9. Negatives cancel out. and the 3 is multiplied to 9. And then negative 9 multiplied by 1 is just negative 9 or minus 9. And so 9 minus 9 equals 0. Therefore, these particular vectors, the dot product shows that it's equal to 0, and therefore they are orthogonal to one another, or perpendicular, or at right angles. Anyway, I hope this little quick video helped, gave you a bit more examples, adding on to the first dot product video. Thanks for watching, and I'll see you around.